Hello everybody and welcome to the Carolam Cymru revision sessions. The session this evening will focus on smart materials and will be presented by me, Rhian Booth. The session will last around 40 minutes where I will run through the relevant content. If you have any questions during the session, please use the question and answer section and I'll do my best to answer these at the end of the session. Also, if you would like to leave your name and email address in that same Q&A box, then we can keep in touch with you with any information about future events. Today's session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Carolam Cymru tab. Thank you and let's begin. Okay, so smart materials, and this is for GCSE level. It's taught in year 11 and let's go. So first of all, the content of the session today. Well, there's not much in fact to this particular theme. However, it's a really important part of the bonding unit. And we're going to be looking at what is a smart material, some examples of smart materials and their uses. Also going to look at some nanomaterials and then finish with 10 exam questions for you to try either with me today, or you can stop and start this if you're watching it as a recording and do them in your own time. Now the boxes, the white boxes that you can see, they are taken from the specification, the WJC specification. The first one is the smart materials that you will need to know. So if I read it as it is, the properties and uses of smart materials, including thermochromic pigments, photochromic pigments, polymer gels, shape memory alloys and shape memory polymers. And then the bottom white box is in relation to the nanomaterials. So the properties and uses of nanoscale particles of silver and titanium dioxide. So those are the smart materials with excellent applications and uses that we're going to be having a look at today. A lot of the content you will find in on the BBC Bite Size page on the website, and also from naturally from WJC. So what is a smart material? Well, smart materials react to a change in their surroundings or an external stimulus, such as a change in temperature, maybe light, moisture, friction, pH, pressure, and other things as well. This is a definition that you should learn. Okay, it could be something that they could ask you in an exam, for example. Designers and manufacturers are utilising smart materials in a whole range of mass consumer products, which often makes them simpler or safer to use. And that is why smart materials are being developed. Okay, you can see in that image there, okay, we've got a smart material that can react to temperature, okay, and you can see the handprint there from the heat, from the body heat, okay, making that mark there on that special paper. That's thermochromic paper. And we also have a similar one where if you can place objects on certain sheets, okay, which are photochromic, and then if you leave them out in the sun, for example, you can remove the objects and you can see the outline of that object on that sheet as well. Anyway, there are more useful uses, let's say, which we're going to talk about. So let's start with thermochromic pigments, which I have briefly mentioned in the previous slide. Thermochromic pigments change colour when the temperature changes. So the term thermo, I'm sure you've heard of that through thermal wear, things you might wear under your clothes in the winter, for example. Well, thermo means heat, okay, and chroma, okay, so maybe you've come across, well, you will have come across chromatography, okay, which is to do with the separation of colour or pigments. Chroma means colour. So if you put them together, thermochromic is to do with a change in colour with the heat, okay, a change in heat. These pigments can be mixed with paints or polymers to give the materials the same colour changing properties as the pigment. Okay, so where might you see thermochromic pigments? Where are these used? Well, I certainly have one of these at home, a colour changing mug. possibly, you're thinking it's not the most useful thing to have, but can be quite entertaining. So certain mugs have different images that appear when you put hot liquids inside. You can see in this diagram here, we've got this white mug, and the mug changes colour when you've got hot drinks inside, okay? Also, in this image, you can see the spoon also changes colour, okay? Indicating that the coffee, the tea, whatever's in the mug is also hot. Really important use, possibly, is bath items for children. You can buy rubber ducks, things that float in the bath, that will change colour if it's too hot. So that gives the parent, okay, an indication as to whether the water is too hot for that child. Okay, so that is quite clever. And obviously you can get some toys like that as well, which are purely for playing with. And then the third example is strip thermometers. Now, I'm sure you've seen these. These are strips of the thermometers that go on your forehead, okay? And they change colour. The different blocks change colour, and that corresponds to a temperature. So that's a relatively easy way to record the temperature of a child, okay? Obviously, on the forehead, possibly not as effective as if you were to put something in the ear, okay? Some kind of temperature probe that they would use at the doctors, for example. However, it is possibly less scary for the child using a strip thermometer, and a very clever use. Okay, so they are your thermochromic pigments. Next, we have photochromic pigments. Now, these work in a similar way to thermochromic pigments, but the word photo refers to light. Okay, so photo is in photosynthesis, then the need for light in order to for plants to grow and produce glucose and so on. Anyway, photochromic change colour with change in light intensity, or when exposed to ultraviolet light. Very useful to have these certain, well, these pigments are very useful. Their applications also useful. So let's have a look at what they'd be used in. Glasses, right, possibly the most common use for photochromic pigments, in fact. When the lenses are clear, okay, so you can see through them, that tends to be when you're inside a building, fine. However, when you go outside and you're exposed to bright sunlight, these lenses can change colour. They will in fact darken in order to protect your eyes from the intense sunlight, okay, the UV light. So that's really clever, and that means you don't have to change between your regular glasses and special sunglasses. You're having that protection instantly. So very good use for photochromic pigment there. Windows in a similar way, okay. Windows will darken if it's intense sunlight outside. That darkening of the windows will again protect you from UV light, or from stopping the room from getting too warm. Okay, so again, a very good use for photochromic pigments here in windows. Polymer gels, okay, also known, probably the most common is hydrogels, okay, where water is a solvent. Polymer gels can absorb up to 1,000 times their own volume in water. That's a huge amount. After this water has been absorbed, it can be released when surroundings are dry, and changes in temperature or pH can cause the hydrogel to release water also, okay, so change in conditions can affect these polymer gels. As I said, hydrogels, we call them hydrogels when water is the solvent, but this isn't always the case, okay. Now, various uses, okay, for these polymer gels. One use is in artificial muscles, okay, where the absorption and release of a solvent, okay, can mirror or mimic, if you like, the expansion and the contraction, just as a muscle would do. This can be used in artificial muscles. It does the same does the same job, if you like. Hair gel, possibly not the most, important use of a polymer gel. However, on applying hair gel, it will solidify. It's the polymer that helps to bind the hair together and gives you that amazing look, okay, if that's what you like. Another use, really important use, especially when I had my young children, was nappies, okay? So inside a nappy, although you can't see the hydrogel, okay, or the polymer gel, there's lots and lots and lots of these small beads, okay, these polymer beads. And what happens, obviously, we know what happens in a nappy. We know what a baby will do in a nappy. We need that urine to be absorbed to the water, to be absorbed instantly, as quickly as possible, because we don't want that rubbing next to a baby's bottom, okay, because that can cause soreness and so on. And therefore, what happens is that gets absorbed in by the polymer gel and is actually then dry to touch. So it's very, very useful indeed. Magic or expanding snow, okay, not as useful, however, lots and lots of fun. Don't know if you've used this at all. At Christmas, for example, I like to play with this. It feels really good. You have a tiny amount of the special polymer gel, or this polymer snow, and when you add some water to it, it instantly expands. So a small quantity can become so much bigger when you add a little bit of water. And that's lots of fun to play with. Also, granules or little beads, similar to Orbeez, okay, will be added to soil and also added to vases and so on, and that will help retain water for plants, okay. So the water can be released when the surroundings become drier. So again, that's something something really effective for keeping your plants hydrated for a period of time. Shape memory polymers are polymers that can be bent out of the original shape and then returned to their original shape when heated. Okay, so let's have a look at the diagram at the bottom to begin with. So we've got the original shape there, which is quite flat. You apply a force and that bends the shape, that becomes a temporary shape. And then all you need to do is to heat that temporary shape, okay, and the original shape will return. So where is this useful? Well, sporting equipment for starters, such as helmets and gum shields. Now, gum shields in particular are specific to your mouth, okay, so we can use these shape memory polymers to produce a gum shield to fit your exact mouth shape, where your teeth are and so on. What you can do is you can heat the gum shield if you want to make it return it to its original shape in order to produce another shaped gum shield. So this is really useful for personalized gum shields. The same with helmets, okay. Helmets are much safer if they are specific to your head and they fit you effectively, okay, and that they're going to be safer in this case. So that's a really good use. Car bumpers, this is a technology that's being developed, okay. If, for example, you bang your car, what can happen is that bumper, for example, can be heated and it will just bounce back out to its original shape. So we're talking about minor collisions here only, okay? But that's a really good use for shape memory polymer. And then the third example I've got here, medical stitches. So if you have a wound which is stitched up, then these medical stitches, which are made from shape memory polymers, will self-tighten as a wound heals, okay? And as the temperature of the body heats up the stitches, that will self-tighten, which again is a fantastic use of this particular smart material. Then we have shape memory alloys, okay? Now, very similar to shape memory polymers. However, these are metal alloys and they can remember their shape when heated. Now, possibly one of my favorite materials is something called nitinol, okay, which is an alloy of nickel and titanium. It's a type of smart material, a type of shape memory alloy, and it contracts when heated, okay, whereas most metals expand. Really, really clever. You can see in that diagram there, you've got a nitinol wire, it's bent into any shape, pop it in cold water, nothing happens, heat that water, and the nitinol wire will pop back into its original shape. Now, I have got some of these, but they are shaped like paper clips, and with a regular paper clip, okay, if you changed its shape, it would stay like that. However, with a nitinol paper clip, you can twist it into all kinds of shapes, pop some hot water on it, and it will return to its original shape, okay? Now, paperclip, you're thinking, okay, is that really that useful? Well, other uses include stents, okay? Now, stents are thin tubes of this shape memory alloy, which can be inserted into arteries. And the reason why they're inserted into arteries is to widen the artery in order for the blood to flow more easily, okay? So preventing a backup, a blockage where blood is unable to flow, which obviously will cause lots of pain to that person and possibly something even worse, okay? So stents, hugely important in medicine. Glasses frames, okay? Glasses frames, I suppose, glasses can be sat on sometimes by mistake. They can bend. Well, if you have glasses frames made of nitinol, then you can simply heat those the glasses frames by putting it in hot water, and the frames should return to their original shape. Now, please just don't try this with any glasses frames, or you might be in trouble when you realise they're not made of a shape memory alloy. And braces, the same, okay? So again, similar use. Okay, we're going to move on now to nanomaterials, okay? What are nanomaterials? Well, a material having particles or constituents of nanoscale dimensions, or one that is produced by nanotechnology. Now, if a material has particles or constituents of nanoscale dimensions, what does this mean? Well, a nanoscale particle is a particle of a substance that is 1 to 100 nanometers in diameter. Okay, really important that you know that bit of information. 1 nanometer being 1 times 10 to the minus 9 meters, which is 1 billionth of a meter. So tiny, tiny, tiny. Okay, we can't see these nanoparticles. Nanoscale particles have very different properties from the normal form or the bulk form of the substance. For example, if we take silver, okay, nanoscale particles of silver are very good at killing bacteria and viruses, and we'll talk about those and where they're used, where the silver and nanoparticles are used later on. But bulk silver is not. It does not have the same properties, okay? Right, let's have a look at the next slide. So more on nanoparticles of silver, or nanosilver particles. Nanosilver is used in wound dressings to prevent infection, to coat the inside of socks and the inside of fridges to kill the bacteria that cause bad smells. Very, very useful. In deodorants to kill bacteria that causes bad smells. So again, silver nanoparticles in deodorants. We use deodorants under our arms and so on, and that will prevent that bacteria growing there. And to disinfect water supplies on the International Space Station. So very important use there as well. Bulk silver, as I've mentioned, does not have any of these properties. It is a shiny metal, it doesn't corrode, it's mainly used in jewellery, okay? But you will need to know the use for nanosilver particles. Another extremely useful nanoparticle is nanotitanium dioxide. Nanoscale particles of titanium dioxide have many useful applications. They can be used in sunscreen to block harmful UV light, okay, and this helps to prevent sunburn and skin cancers. These particles are so small that they cannot be seen and so make the sunscreen invisible, which is very useful, I would say. I remember as a child being smothered in sunscreen, and you could see that I was, because my whole face, body, everything was completely white, almost glowing because of all the sunscreen. So it's great that that these sunscreens are now developed so that that they can't be seen to be wearing it. Titanium dioxide nanoparticles can also be used in self-cleaning windows, as they can break down the dirt on the surface of the windows. Another really clever use, okay? Anything that helps with cleaning, then I'm for it. So self-cleaning windows, this sounds like a fantastic use of the nanoparticles of titanium dioxide too. So it all sounds good, but do we have any concerns? Are there any concerns regarding nanomaterials in particular? Well, use of nanoscale particles is relatively new. It's a relatively new technology. So at the moment, we are uncertain of what the long-term effects are, okay? The particles are so small that they can easily pass through our skin and into our bloodstream. So this may be of concern. They may even be small enough to enter our cells or the cells of other organisms, the effect of which is also still unknown, okay, because it is a new technology. They could enter the environment very easily and could cause harm to plants and animals. And nanoscale silver is used in washing clothing because, as we know, okay, it kills bacteria that releases harm, the smells, okay, the unpleasant smells. However, the nanoscale particles can enter the water during that washing process and therefore enter the environment. Now, due to their antibacterial properties, they could cause a lot of damage to bacteria within the ecosystem over a long period of time. Now, these are all our concerns because we have no evidence, we have no proof, because it is a very, well, a relatively new technology. And therefore, these will, the long-term effects will be made aware to us in time. Okay, so there are some concerns. People are concerned for these reasons. Okay, so what I have for you now are 10 exam style questions around the topic of smart materials and nanomaterials, nanoparticles. What I'm going to do is I'm going to pause between each question to give you a little chance to answer those questions. If you do need more time, remember you can watch this back, okay, and you can pause between questions to give yourself a little more time to answer the question if needs be, okay. But for today, there will be approximately a minute between each question for you to have a go if you're following live. So question 1, nanosilver particles can be used in socks, plasters and disinfectant sprays. Explain why nanosilver is suitable for use in these examples and state why some people are concerned about the use of nanoparticles in everyday life. So this is worth 3 marks. We have just discussed this, so hopefully it's nice and fresh in your head. But I'm going to give you just under a minute. Off you go. Okay. So just have a look at the answer. Let's see. So on the right-hand side, you have the answer from the mark scheme. Okay, so Nanosilver has antibacterial, antiviral, antifungal properties, so kills germs. Any of those would have been accepted. Okay, and that's why, of course, it's suitable for use in those examples. But why are some people concerned about the use of nanoparticles in everyday life? Well, they could be absorbed through the skin, breathed in, and for the third mark, long-term effects are unknown. Okay, so there you have the answers for that particular question. Question 2 then. The box contains the names of 4 types of smart material. We have thermochromic pigment, shape memory polymer, hydrogel, and photochromic pigment. Use the information given to complete the table. Right, so in this table, what you need to do, is if we look at the first example, the unusual property is it regains its original shape on heating. A use would be in car bumpers, and the type of smart material would be a shape memory polymer. Okay, now for the following 2, so changes colour with change in temperature, and it can absorb up to 1,000 times its volume of water. Pop down the type of smart material that would do that in both of the columns, and then choose a use. Okay, so there are multiple correct answers for this. So give me a use for both of those smart materials. So I'm going to give you just under a minute. Off you go. Okay, a little bit more time. What is the smart material, and can you give me a use for that smart material? Okay, right, let's have a look at the answer. So, thermochromic pigment is smart material that changes colour with change in temperature. And then the final one in the table, it can absorb up to 1,000 times its volume of water. That will be a hydrogel. Okay, and the examples that they have chosen is a baby bath thermometer for the thermochromic pigment and nappies for the hydrogel. If you have put any other uses there, correct uses, then you would get the mark. Okay, well done. So question number 3. We have uses on the left-hand side and properties on the right. Now, all you have to do is to draw a line between the use and the correct property. So the let's have a look at the use actually to begin with. So nanosilver in dressings for cuts and burns. Why is it used for that? What's the property that makes that suitable? And then nano titanium dioxide in sunscreen creams. What property do you think would match up with that one? So I'll give you less time for this. Okay, so if you can match those up, I'll come back to you in around 30 seconds. Okay, I think that's probably enough time. So let's have a look if you've got it right. So nanosilver is used in dressings for cuts and burns because of its antibacterial properties. And finally, nano titanium dioxide is used in sunscreen creams because it blocks harmful UV light. Okay, well done. Question number 4. Smart materials are used to make the frames and lenses of certain spectacles. Give the names of the different types of smart material used and describe the unusual property of each. So have a look at those spectacles. We want the different types of smart material used in those two and describe the unusual property of each. Okay, off you go. You've got around a minute. Okay, so a little bit longer. Okay, so let's have a look. So this is for 2 marks. So give the names of different types of smart material used and describe the unusual property of each. So in terms of the frames, to begin with, they are made from a shape memory alloy, and this regains shape after bending. Okay, so you can use some heat there to regain shape. And then in terms of the lenses, well, this would be a photochromic pigment because it changes colour with changing light intensity or sunlight. Okay, so hopefully you can see the connection with those two. Well done if you got those correct. Right, we've reached the halfway mark with the questions now. We're on question number 5. Titanium dioxide has been used in sun creams for decades. Sunscreens available today use nanoscale titanium dioxide particles. Some people believe using creams containing nanoparticles is unsafe. So part 1, give the advantage of using nanoscale titanium dioxide particles rather than larger titanium dioxide particles to make sunscreens. And part 2, explain why some people are concerned about the use of nanoscale titanium dioxide particles in sunscreens. Okay, so there's 3 marks in total for these two. So off you go. I'm going to give you a minute, see if you can answer it. Okay, we're just over halfway. Hopefully you can see as well, a lot of these questions are very similar and asking very similar things. So just make sure you read the question carefully in order to get get full marks. Okay, I think we're ready to move on. So let's have a look at the answer. So give the advantage of using nanoscale titanium dioxide particles. Well, these are, the cream will appear transparent rather than white or opaque when applied. Okay, they will also accept clear rather than white. Okay, or transparent rather than white. And then finally, why are some people concerned about the use of nanoscale titanium dioxide particles? Well, it can or could pass through the skin, get into the bloodstream, get into the body, so something along those lines. And also, long-term effect is unknown, okay? Could be toxic buildup over time. We don't know this, okay? Toxic and poisonous is also mentioned there. So question 6, a little bit of maths for you now. Approximately how many times bigger are common titanium dioxide particles than nanoscale titanium dioxide particles? Okay, just giving you the size of those particles there. So the common titanium dioxide particles are 3 × 10⁻⁷ meters, and then nanoscale titanium dioxide particles, 2.5 times 10 to the minus 10 meters. Okay, so how many times bigger are the common titanium dioxide particles? Show your workings out if you can, and let's see if you can come up with an answer. Off you go. Okay, let's have a look then. See if you've got this correct. So the answer, okay, is 10 to the power of 3 or 1000. We'll also accept 1200, okay? And also, if you've shown your workings out and you have divided 3 times 10 to the minus 7 over 2.5 times 10 to the minus 10, which will give you the 1200, the 1200 answer, you'll get 1 mark for that, okay? But we're looking at the difference. So think of how many times bigger one is than the other, okay? And if you put down 1000, well done you get the full marks for that one. Question 7 is loosely connected to this topic, okay, because it mentions silver. But let's see how much you remember, because obviously this comes into the bonding unit anyway. So the following diagram can be used to represent the structure of silver. Select the correct words from the box to complete the sentences that follow. Okay, so we're looking for 3 words in total here. Silver is a solid because the metal ions are blank, packed. Silver is a good conductor of electricity because the blank are delocalized and free to move. And silver dents when hammered because it is blank. So which 3 words from that box do we need to insert into those sentences? So I'll give you around 30 seconds to do that. Okay. Hopefully that was a nice, easy one for you. Let's have a look at the answers. Silver is a solid because the metal ions are tightly packed. Silver is a good conductor of electricity because the electrons are delocalized and free to move. And finally, silver dents when hammered because it is malleable. Well done if you got those. Question 8. Silver can also exist as nano-sized particles. These are used in plasters, socks, and deodorant sprays. Underline the correct word in the brackets to complete each sentence. So we have 2 sentences there. Nano-sized particles, silver particles range from 1 to 100 millimeters, 1 to 100 nanometers, or 1 to 100 centimeters in size. So underline the correct one or just write down the correct one. Nano-sized silver particles have the same, different, or stronger properties compared to bulk silver. And then finally, give the property of nano-sized silver particles that allows them to be used in plasters, socks, and deodorants. Off you go. Okay, so let's have a look at the answers. So nano-sized silver particles range from 1 to 100 nanometers. They have different properties compared to bulk silver. And finally, the property that allows them to be used in plasters, socks and deodorants is, of course, that they are antibacterial, antifungal, kills bacteria, antiviral. One of those would be fine. Okay, well done if you got those correct. We've got 2 questions remaining. Okay, so question 9, another little maths question for you in relation to nanotubes. Carbon nanotubes can be formed by rolling up graphene sheets. A sheet of graphene 11 unit cells in width was rolled up to form a nanotube. Use the information below to calculate the diameter in meters of the nanotube formed. Write your answer in standard form. So they've given you here the equation, which is circumference is pi times diameter, and they've also told you what pi is, which is 3.14. And 1 nanometer, of course, is 1 times 10 to the minus 9 meters. So can you please calculate the nanotube diameter? Make sure you have a look at the diagram, which tells you what 11 unit cells are in width. Okay. And notice from that diagram, it tells you what the width of the 1 unit cell is. Okay, so I think that's probably enough time for that one. Let's have a look at the answer. Right then, so the answer, if you got 9.1 times 10 to the minus 10, well done you, full marks for that. Okay, so just to go through it in case you weren't sure, it gives you what the width of 1 unit cell is, which is 0.26 nanometers. Now it's told you that the circumference is 11 unit cells, and if each one of those is 0.26 nanometers, then you need to multiply 11 by 0.26. That gives you 2.86 nanometers. And then you need to rearrange that equation to give you diameter is circumference divided by pi, so that's 2.86 divided by 3.14, which will give you the answer that is needed for the diameter. Okay, so well done if you got that correct. And finally, for you, okay, hopefully this has been useful, but your final question is a nice easy one, I think, to finish on. Draw one line from the property of the carbon nanotubes with the correct explanation. So we've got the property on the left-hand side, and we've got the correct explanation or reason for those properties on the right-hand side. You just have to choose which one. Okay, so which one would correspond to high melting point and which one would correspond to conductor of electricity. So I'm going to give you 30 seconds. Off you go. Okay, and almost there. I think that's probably enough time. Let's have a look at the answers. So the reason for the high melting point is because there are strong bonds between the carbon atoms. Okay, and the reason why these nanotubes are conductors of electricity is because there are free electrons which can move. So there we have 10 questions and some information all about smart materials for you. Hopefully that was helpful. Okay, make sure once more you have a look back over this PowerPoint, attempt the questions. You don't have to watch me, of course, you can just have a look at the PowerPoint. Some of you might prefer that anyway. But look forward to seeing you next week for another GCSE session. Have a lovely evening. Bye-bye.